vehicles, so the automotive industry, truck industry, off-highway vehicles, medical devices, IoT devices. If you're doing a standard information security risk analysis onto a machine, then you probably will not end up with adequate security at the end of the day. In this talk, we're talking about the key points that are to be considered from our perspective and our experience out of hundreds of projects in this field, requirements that you need to meet so that you can really get all the things done that you need to do in a risk analysis.
Welcome to talk.cyberscni.fr.
Bienvenue.
Welcome to Talk Cyber CNI today from a new location from Munich, from the TUM. Welcome to your monthly cybersecurity speaker series. And today we have Sebastian Labitzke from ITK Engineering with us. But before we start with the talk, let me first start with something interesting for some of you, namely together with the chair and the German-French Academy for the Industry of the Future, and also the ACM, the Pôle d'Excellence Cyber in La Région Bretagne, and of course IMT Atlantic. We run a PhD school on IoT meets cyber and security. It will happen in Rennes from the 29th of November until the 1st of December. So the full week packed of an interesting program. You will have keynotes from industry and academia. You will have the possibility to present the research that you're doing. You will have lots of hands-on sessions. You will have challenges that we will be working on during the week that you will present on Friday in front of a jury. We have prizes for the best teams. You will be able to discover Rennes, a very nice city in the northwest of France, and many, many more things. And the good thing is it's an hybrid event, so you can physically come. You find more information on the slide that you see here. So when you go to school, future-iot.org, you find the program and lots of more information. Please share this info with interested students and friends of yours. And the good thing for those who will not be able to make it on site is that we also have two possibilities for remote participation. The first possibility is that you participate via Zoom. So you can dial in and you can participate. You can also ask your questions. And the second possibility is that you participate via YouTube or LinkedIn or Facebook, because we also live stream the event, like we stream today's event to all the channels, and you will also have the chance to participate using these channels. All right, that's it. So please visit the website and have a look at that. I come to the next point, which is, as usual, our Slido, and today's Slido link is cybercni/11, and as usual, use it as a second screen. Go to the website and ask all the questions that you have there, and at the end, after the talk of Sebastian, we will have 45 minutes roughly for discussion and questions as usual. And this is an equally interesting part as the first, if we have good questions. And so therefore, please take a look, get inspired, because there you see also which questions were already asked. And Alex is also today with us. He will moderate the session at the end. So I'm already looking forward to this session. Good, so let me jump back to the overview slide. So today we have Dr. Sebastian Labitzke from ITK Engineering GmbH in Germany. Sebastian will talk about cybersecurity risk analysis reaching the full potential. Sebastian He's the head of engineering. He's of ITK Engineering. He's responsible for topics like cloud development, data analytics, industrial systems, and energy management projects. Furthermore, as Chief Information Security Officer and Product Security Officer, Sebastian drives the information security management system based on ISO IEC 27001 TISAX and is responsible for the security of project deliverables. Sebastian represents the ITK Engineering GmbH, which is a 100% subsidiary of Bosch, in committees and by giving conference presentations, keynotes, online seminars, and online videos. More background about Sebastian is on the website. And without further ado, Sebastian, I would hand over to you. I'm really looking forward to the talk, and I'm sure the audience does so too. And yeah, looking forward to hearing about the cybersecurity risk analysis. Give me 1 second, because we had some technical difficulties, which will be resolved in 1 second. So, good. Okay. Yeah, this is always live. So Sebastian should be coming. Yeah, there you are. So I switch over to you, and now you can really start looking forward to your talk.
Thank you, Mark Oliver. And again, thanks for the warm welcome and the nice introduction. First observation of today for myself is the older you get, the longer the CV presentation gets, which is kind of funny and something that I observe over the years. I'm really looking forward, and I welcome all of you on the different channels like Facebook, LinkedIn, YouTube, what channel is running and on air for today's presentation on cybersecurity risk analysis, reaching
Oh. So yeah, we just lost Sebastian. Sorry for that. So we'll be back in a second. And in the meantime, dial into the Slido on the left. And yeah, then you can join us on the second screen. If it will not work out, then we also have a backup possibility. So let's just wait until if Sebastian is connecting again. In the meantime, Alex, we can discuss a bit what we expect from the talk. So what are you expecting from the talk?
Yeah, thank you, Mark Oliver. Yeah, I have to cut the YouTube channel because I have the delay.
Oh yeah.
So I'm just wondering how can we analyze some very specific risks. So how are we able today to manage and to analyze every kind of risks that can occur to companies or to specific tools? So that's my big expectations for this talk.
And that's very good expectations. And so what I'm looking forward to as well is that we heard a little bit something about EBS, the method from All4Tech some weeks ago. And therefore, as Sebastian is back, and therefore this will also be interesting to compare a little bit what are the steps to be taken in that direction. So, Sebastian, can we hear you?
Yeah.
Oh, perfect.
I can hear you
Great.
clearly.
Then we can also hear you. So your slides are also visible. I will configure the rest in the meantime, but and he's again. So the question is, if we switch, I will just open a Zoom. Yeah, and risk analysis, of course, is a key challenge for cybersecurity because from the risk analysis, you define which measures are useful to take because it's always a trade-off between security and costs. 100% security can be infinitely high costs, and that, of course, you cannot give. And yeah, it's also great to have Sebastian because he's a practitioner for many years, has lots of experience in the domain, and has different use cases than those that we heard with All4Tech some months ago.
Yeah.
So let's just start this meeting. And check if that works better for Sebastian. Even though I fear personally that it's maybe a connection issue.
No.
Do you think, Sebastian, that a Zoom link would help you?
Maybe that helps. So I'm reconnected via another browser now. Maybe that's
looks good. So far it looks good. I already put you the Zoom link as backup to the chat, but if we would stay in this tool here and for the moment it looks quite good, that would be better.
okay. So trying to manage to share the slides. Can you see the slides?
Not yet.
Is it now working?
Okay, the slides are coming. Yes. So then give me a second, and it also looks like much more stable. So I'm confident that now we have a running setup. In the meantime, we were already discussing a little bit about risk analysis and the importance for cybersecurity.
Great.
So the audience had something to listen to at least. All
That's
right,
nice to hear. Sorry for any inconveniences, but this is live, actually.
Yeah, exactly.
So we've tried the one browser. Hopefully it's more stable now. Give me a sign whenever I'm breaking.
Yeah, so alle guten Dinge sind drei. And so, yeah, I'm looking forward to your talk. And here we go.
Yeah, thanks again, Mark Oliver, for this nice introduction. Warm welcome. And I'd really like to welcome all the audience via the Facebook, LinkedIn, YouTube streams watching our today's presentation. I'm really looking forward to the next 1.5 to 2 hours we have in here. And I'm looking forward to all of your questions because I could manage to bring all in the technical talk that I try to deliver as entertaining as possible for you today. However, I've started with 2 or 3 words about ITK Engineering. I make it short. I don't want to advertise the company too much today, but it's really great to work here. It's a 100% subsidiary of Bosch, and ITK, if you're asking me, managed to hire 1,300 of the best engineers in the world to do business around the automotive industry, the commercial vehicle industry, so trucks and other things like that, agricultural machinery, medical devices, IoT devices, industrial systems like industrial systems 4.0 things, smart products, smart factories, and such. So it's an amazing environment where you can set up cybersecurity. And we've already started to do that in 2008 when no one in these industries I've just sketched were able to put budget on the topic of cybersecurity. In the IT sector, that was already common, but not in the world of electronic control units and all the machinery around that. So I'm really happy that 2021 is something completely different. We have a topic that is in everyone's mind, also in these industries. And now we are fine-tuning all the things, all the artifacts that are necessary to build up for an adequate level of cybersecurity. And this is what I'm going to talk about today. And I'd like to start with one of my favorite quotes by Stefan Inapo, who said, "It takes 20 years to build a reputation and a few minutes of cyber incident to ruin it." And that's our whole motivation why we do cybersecurity. Isn't that the case? And if we are talking about risk analysis, then we are talking about building models. And George Box once said, "All models are wrong, but some are useful." And the question for today is, what kind of models are useful in the context of risk analysis? And this is basically the foundation of today's talk. So let me start with a slide that I probably show in every of my presentations. And if you have seen one of my presentations, I'm sure you know these next two slides. And sorry that I show you again, but if there's anyone who didn't see it, I'd like to show it because it is really my favorite slide. How much cybersecurity do we need? And there is a saying that is completely wrong. It's from a talk of Joshua Corman, who said, "You don't have to swim faster than the shark, just faster than your body." And what's wrong here? And Joshua Corman also pointed that out, that this sentence is completely wrong. I mean, the tank of sharks is like that. There is not only one shark, there is a whole bunch of sharks trying to attack the one or the other, maybe you tomorrow, maybe today, maybe in the future, you don't know. So this sentence is completely wrong. Maybe funny story I always tell about that picture. I've asked our marketing, get me a picture with really dangerous sharks. And what I get is this picture of hammerheads. They are kind of harmless. And I was thinking about it because even the teethless tigers in the world of the attackers, maybe researchers who showed that a vehicle is vulnerable, can cause a reputational damage, like we have seen with the Jeep hack that caused a reputational damage for the company, and other hacks we have seen so far. So it's not only the really dangerous sharks that are hurting a company, but maybe sometimes a research talk also that we need to have on the conferences. People should show the vulnerabilities first to the companies, maybe to the public if that is needed, but that can cause reputation. And our today's focus is cybersecurity for road vehicles, and the interesting thing is, why the heck do I need cybersecurity? I mean, a couple of years ago, those vehicles were disconnected systems, enclosed systems that are working on themselves and were not connected to the outside world. But this completely changed. We have Wi-Fi, we have telematics units, we have V2X communication, vehicle to infrastructure, vehicle to vehicle communication like that. We have, of course, Bluetooth. You are connecting your mobile that has an internet connection with a vehicle. You are maybe doing platooning if you're riding trucks, right? So platooning is driving trucks close to each other, and they are communicating with each other to reduce the distance in between the trucks so that the road consumption can go up without going in a traffic jam situation and things like that. So many examples that show that the connectivity or the amount of connectivity increased over the last decades. And the security thing is essential to offer these services. It's not a feature people would click in the car configurator as an add-on they want to spend $300 more for. It's something that is demanded. If you're buying a device, whatever it is, it doesn't need to be a car or a truck or something like that. If you're buying an electronic device, you're demanding security. right? And the question is, how can we secure such complex systems with different stakeholders in super complex environments? And the answer could be that we're following a strategic process, right? But where to start? We have seen a lot of approaches so far. I said already that we've started 2008 with doing cybersecurity for electronic control units and systems out of electronic control units, and we have seen many approaches. Um, some of them are leading to good security, and some of them are not leading to that, depending on the company, the culture of the company, and things like that. But here we have an overview. There are those companies saying, this little bit of security I can add to the system on my own. It's obviously something you can quickly start with. It's independent from third parties. It's a trust thing. You just need to trust yourself. But on the other hand, you need the experts. And it's hard to hire the experts. It's absolutely recommended from our side that every company has its own cybersecurity experts. But it is a huge invest, and it is super hard to hire the experts. And there is no one-size-fits-all products. If you're going to a conference, and there are talks by companies, I've seen many of them, who are trying to advertise snake oil systems, like if you're deploying our system on your vehicle, then your vehicle is secure. Forget about it. That's not the case. Yeah, there is a lot of potential to forget something because the things are super complex. And to show you how complex the system is, I have kind of a list of things you need to consider, and this is by far not complete. So here are some exemplary cybersecurity goals like authenticity, integrity, confidentiality, availability, intellectual property, theft protection, tuning prevention, protection of personally identifiable information, so all the privacy things. These are just some of the cybersecurity goals that could be relevant for your system. And there are so many controls, the countermeasures you can apply to your system, like onboard communication that needs to be secured. So if you have 2 or more electronic control units in your system, 1 or more computers on your system, then you want to have communication that is secured. Secure boot, you just want to boot the things that are coming from you or your supplier, but you don't want to boot something an attacker brought in, right? Runtime manipulation detection, secure access, secure update, OTA things that need to be secured, remote diagnostics. You need to have secure software architectures and secure networks, of course, secure wireless communication, whatnot. So there is a slew of controls that you can apply to your system and that you configure based on what you need in terms of the level of security you want to have. And there are so many meta topics to consider. So there are things like secure coding, hardware security modules, security libraries you want to bring into your systems, crypto parameterization. You cannot just throw a crypto algorithm on a device and say, okay, run for me and make it secure. It needs to be implemented securely. It needs to be parameterized securely. And secure key handling, for instance, in this context is an issue that you need to solve. Freshness in the system of the messages is something that you need to consider so that no one can replay messages and attack your systems via that. So there's a lot of things you need to consider, and if you don't have the experts, then it's really hard to approach the topic of cybersecurity by the you can do it approach. You could establish the process first. It's a very holistic approach, and it is a good preparation for compliance audits, but it takes time. It's hard to get the budget. Tell your management, hey, we need a cybersecurity process for our system. And they would say, okay, what about the vulnerabilities of our system? How can we estimate how large the budget should be and things like that? It's a really abstract approach, and latest when you're showing up at your management, you can instantly recognize that this is very abstract and not graspable for the people who are releasing the budget for that or approving the budget for that. However, this process can be a good starting point. And then we're coming to the point of risk analysis. So risk analyses are a quick start on a specific project, a specific system, a specific component with a strong focus on this system. It eases the budget discussions because a risk analysis, if it is done in a decent manner, and we're talking about that later on, it really is not a super big effort. Depending a little bit on your system, if you have a super large system like a whole vehicle or something like that, that could be something that takes some time to come up with. However, at the end, there is the potential that you have decision basis for your management, what to do, where to, how high the budget needs to be, and things like that. But it has also the potential to get lost in the details. You need to tailor the method on the fly sometimes. There is a lot of potential to forget something. Like if you have an expert on the communication level, you might focus in your risk analysis on the communication part, whereas the thing what gets booted on your device gets a little bit in the background. It takes time, of course, and system knowledge and experience on potential attacks. That's for sure. So our recommendation is focus on one first cybersecurity artifact and one component, and then expand your methodology a little bit further. And the thing, I would say the worst thing, but that happens every day, is you already have a product and someone got the fantastic idea to secure that. Now at the end of the line, and you know, the later in the process you start to change something, the more expensive it is. Yeah. Retrofitting, of course, you can quickly start with that. You have a specific project. It's easy to communicate to the management, and it fits to some company cultures, and that's interesting. Some companies can really handle this retrofitting approach, even if it is not the best approach we would recommend, but some companies have the culture to do that. So I don't want to bash that. And it happens, as I said, from day to day or every day. And but on the other side, it has a lot of disadvantages, like the potential to get lost in attack discussions. Like, I know this attack, and I've heard about the media stuff here, and they told that something. It's a long discussion. We have seen quite often in our projects. Consider just specific countermeasures is also a problem. Being completeness is something you cannot prove, and it is never there. But there is the aspiration to be as complete as possible, and that is not possible with a retrofitting approach, or it's hard to reach, I would say. And typically, it does not result in a structured process. It's maybe late in the process and high cost of change, as I already said. It's unsustainable, but it is a fast approach on the other hand. So many approaches, and maybe you are laughing while these approaches are ongoing, but the context situation dictates sometimes to start with one or the other approach. So as I said, we see everything, but here is the blueprint for what a decent approach looks like, which is follow a security engineering process and follow the divide and conquer approach if you have a big system. So divide it in parts and conquer the individual parts, and then glue it together to an overall cybersecurity concept with a decent risk analysis. And what helps here is that there is a new standardization and also a UNECE regulation that applies for road vehicles in the future. That is kind of interesting. So it's a standardization on the process for cybersecurity for road vehicles. It's the ISO SAE Joint Standard 21434, finally released in August this year. We have also done a YouTube video on that. If you want to have more details on the standard, we're talking about some risk analysis parts of it later on. but it's really interesting because the UNECE regulation affects the road vehicle type approvals. So you will not get type approvals for the vehicles in the future if you haven't done a decent cybersecurity process as an OEM company, but also as the suppliers, because the OEM companies will forward the requirements for the UNECE regulation to their suppliers. And there is a standard that claims to be a reference implementation of a cybersecurity management system, the thing is by the UNECE. So the UNECE is the general regulation that goes into the laws of Europe, also Japanese law ratified already a law on that. And ISO SAE 21434 is the standard that you can follow to really reach the goal of having a cybersecurity management system. It's already out, as I said, mid of 2021 was the last plan, and they made it in August. We had the final standard. It now provides a common understanding of security-related activities for vehicles, and it has a security by design approach. So this retrofitting and things like that is no more possible, right? Documentation of security engineering activities is the central part of it, and it also defines the interfaces between the stakeholders, as I already said, the OEMs and the suppliers and the legal entities, the type approval institutions and things like that. It's the state of the art. It will be the state of the art by law, at least in Europe and Japan, and also countries like China are jumping on regulations based on these standards and regulations. And the thing is, the risk analysis is a central part. Without a risk analysis, you wouldn't get a type approval in the future. And this is why we are focusing on risk analysis. And if you're talking about risk analysis, we know what risk analysis is. If you're standing at the traffic light, at the pedestrian light, and it is red, and you're looking to your left and your right, and you don't see a child, then you're doing a risk analysis. Is it worth to cross the street if the light is red, right? The upper left picture, that's actually me in a race car. It's in Zandvoort Circuit. It's a really nice circuit in the dunes of the Netherlands. This picture was taken at a speed of 180, 190, close to the first turn after the finish line. And it's also risk assessment, right? I'm deciding, is it a cool idea to run with 190 with a turn in front of me, or is it a bad idea, right? And when do I need to brake this machine, right? So that's what risk analysis is all about. And cybersecurity risk analysis is part of the overall risk management that everyone needs to do for their products and such. And it provides a decision basis, as I already said. The thing is, I've asked around our risk analysis experts and did a little survey throughout the large teams of cybersecurity doing the risk analysis. And I've asked them, what's from your perspective, what's the actual purpose of a risk analysis? And that's pretty interesting. A bunch of answers. So with a risk analysis, executives understand risks. It's a decision basis, as I already said. It prioritizes the risks. It prioritizes the security mechanisms that I need to deploy. And this is a cost optimization because some mechanisms I might not want to deploy after a decent risk analysis because the effect is maybe too low to get an adequate security level. And it is good to find out what is not necessary to cover. It's discovering the weaknesses of the underlying architecture. So it really digs deep into the architectural discussion, which is definitely a benefit in the development of the system. So the security guys are trained to ask the hard questions, the tough questions for the architecture. And we've seen that so many times that just discussion on the risk analysis changed the architecture to make it better. And the purpose for changing something was not the security, but the security discussion triggered that. And this is exactly what another guy said. He said, for me, it triggers the essential discussions in the process. It identifies the attack potential you would not have thought of. And it is the basis for a residual risk analysis. So after you have done all the security concepts and things you want to implement on the security side, it gives you the basis to, or the foundation to really do a risk analysis based on the residual risks that stay in the system, even if your security measures are active. It improves the incident response. So imagine with your product, something happens in the market afterwards. Then you can go back to your risk analysis and try to figure out where is this incident located in your risk analysis, and you can instantly derive the risk potential for your company for that. And it's state of the art. And of course, judges will love to see it if you have it, if something happened, like something was able to deploy an airbag at 180 at the Autobahn. Then maybe judges will ask who are guilty of that situation. And if you have a risk analysis and it is covered in there, it probably betters your position of negotiation in that court case, right? So let's talk about some things of risk analysis. Let's talk about the bare necessities. What do I need to have to do a decent risk analysis? And afterwards, I want to pull out three things that one colleague of mine, Tobias Nilges, is always highlighting, the three main characteristics a good methodology on risk assessment or a good risk assessment should come up with or should fulfill, which is methodology, flexibility, and traceability. And at the end, I will sum up my talk of today. So let's talk about the bare necessities of a risk assessment. I've already said that a risk assessment starts with modeling the system. And I already said all models are wrong, but some are useful. The question is, what can lead to a useful model of the system? And I would say it should decompose your system into subcomponents and listing all the interfaces, listing all the connectivity the system has. It should come up with a really good understanding of the system modeled in the risk analysis. Afterwards, we're talking about the identification of attack paths. We would recommend an attack tree approach. We are coming back to that later. And it tackles the topic of threats, damage scenarios, weaknesses, vulnerabilities, and all these things. So that is the expert work of the security engineer that is going into the system model and enriches the system model with information from a perspective of an attacker. Right. And then there's the risk assessment, which is impact rating, attack feasibility rating, and a risk matrix. You may wonder why here it is called attack feasibility rating and not likelihood rating or something like that you might have heard before. So the classic risk matrix consists of two axes, which is the impact axis and the likelihood axis. And if you're combining the two I would say ratings, then that leads to a risk value in your risk matrix. We are talking about attack feasibility here because we don't have the empirical data for vehicles to really derive a likelihood of an attack. So what we are doing is we're analyzing how feasible an attack might be for an attacker. Yeah. And coming back to the ISO SAE 21434, there are, it's 17 requirements, sorry, that's a typo, 17 requirements for risk analysis, tackling the problems I sketched earlier. So There are the definition of damage scenarios, associated impact ratings, definition of assets, derivation of threat scenarios, derivation of attack paths, and associated likelihood ratings or attack feasibility ratings, as I said. And it determines the risks, or it requires to determine the risk, and there is the risk treatment. And if you draw that onto the three parts of the risk analysis I've shown you earlier, then you can instantly see that there is the system model, which is the damage scenarios, the assets, and the threat scenarios. There is the identification of the attack paths, which is the requirement 15-08. And then the actual risk assessment, which is the impact rating, the likelihood rating, the determination of risks, and the determination of risk treatment. So that's basically the structure of a decent risk analysis that is also demanded by the standard ISO SAE 21434 for road vehicles. But there are also customizable parts that are not standard. So it's your attack feasibilities, and of course there are some best practices in the standard and also some requirements on that, but you can do it the way you want to and what is best for your system. You can, for instance, potential CVSS attack vectors, attack trees, and things like that to do that. And then the attack feasibility levels, AFL, need to be propagated. I said earlier that we want to divide and conquer the system, right? So we divided it in subparts and found out different attack feasibility levels for each subpart, and now we need to propagate that to the root node of our divide and conquer approach. And of course, the attack paths need to be documented, and we're talking about that a little bit later in the methodology sector, where we talk about component views, where's it function views, available information, need for prioritization. And there is a clear how to document the risk analysis artifacts, as I already said, where we have to balance the clarity and the editability of that. And that leads to the point of flexibility in order to fit into overall development processes. And we need to have risk analyses that can interplay with other artifacts, like residual risks that need to be evaluated. And the risk analysis might be an interface between you and your supplier or your customer. So the thing of traceability comes up because we want to trace all findings to allow easy review and communication of the results. So a little bit more on the bare necessities, and then we're coming back to the three things I've stated recently. So the bare necessities are sufficient to satisfy requirements. But if you're just doing it and you're not thinking of methodology, traceability, and flexibility, you will end up in a document and you're just doing paperwork that goes in the desk and never sees the daylight, right? Because it's not of many value, right? If you're just optimizing to fulfill the standard, then you might not end up with a risk analysis that has additional value for you, right? Many questions are left unanswered by norms and regulations. The methodology is not fully specified. Risk analyses need to be flexible to become a living document. As I said, if it is put on in the desk afterwards, then it is not of value. Information flows and traceability of risk analysis inputs and outputs are only roughly sketched. So that is something you need to think of. And there is a chance. There is not only something that is disappointing on that. There is really a chance and a need to have this flexibility because you need to integrate the whole risk analysis project into your company-wide development process. So it's crucial to identify all the requirements within your organization, and afterwards you should think of the three main characteristics of risk analyses, which are methodology, flexibility, traceability. If you want to hear more of that, I've already referred to my colleague Tobias Nilgis, who is a real expert on risk analysis. He has done also a YouTube video on our cybersecurity YouTube channel, which I recommend to subscribe to. And comment the videos. We are open to do something that is of interest for you. So go on YouTube and try to take part of that journey of the cybersecurity channel of ITK. That's really worth watching. What the colleagues did. I'm not talking about my own videos, but at least the videos of my colleagues are really, really worth watching. Yeah, methodology is the first thing that we want to tackle. One size fits all, is that the solution? Obviously not. There are many approaches. I've already said some of them. There are more, but there is one result out of the analysis of these methodologies. There is no one size fits all solution. There's also no wrong approach or wrong method. Every approach has its disadvantages and advantages. Have some boundary conditions that have to be considered. Are you in a component view, in a function view, in a system view? That makes a large impact on the picking and choosing of methodologies. The maturity of the system goes into this decision. Is it a concept stage or a proof of concept, or is it an already implemented solution? There are information that must be shared with customers and suppliers. For instance, the CIA. You can compare a CIA to the developer interface, development interface agreement, like it is done for safety. ISO 26262 is the standard for safety for road vehicles. And the CIA is an acronym that is already used in the security. However, here in this context, it stands for Cybersecurity Interface Agreement. The question is, do you want to reuse risk analysis artifacts? Is the basis of vulnerability analysis during incident response, and so on and so forth. So many things to consider when choosing a methodology. And every methodology has its own, let's say, specific things to document that. You might want to have a textual description which has low initial overhead, but it is also not flexible if you need to adapt something. If you just list individual attack steps, then you're in between. And then we're talking about the attack trees I've referred to earlier. And I want to come to this, maybe for the sake of time, I'm jumping over the examples and show you an actual attack tree that is about a hack on airbag systems. It's a published research work, so we can talk about this attack tree. It's a part of the research work, a tiny part of it, but I can show you a little bit how an attack tree works. So up here, we have a damage scenario, which is called D, and an indicator like the 2, which is suppress the airbag and belt tension at deployment. And below that, you have all the paths that can lead to this damage scenario. So the thing that you can spoof safe conditions, and there is a threat scenario how you can do that. You might have recognized those little operators here. There is an AND operator, in most cases represented as a plus sign, which says if you want to reach this level as an attacker, you need to go through all the steps below that node. If it's an OR node like here, you need to do one or the other path as an attacker. So you need to exploit one of these vulnerabilities to get to this stage. You need to do all the things here to get to this stage, and so on and so forth. And if you make it up to the root node of the tree, you are in the damage scenario, and you have finally reached your goal as an attacker. You have already recognized it's the attacker perspective that drives the cybersecurity engineer through the attack trees. And then you need to rate that. You have seen that there here some color coding. I don't want to go into the details, but what is behind that, it's a rating scheme that you can use to rate the nodes. And actually, what is done here, you're rating the vulnerabilities, which are the leaf nodes of the whole tree, indicated with a V and an ID. And then you have a mathematical model to propagate that up to the damage scenario, and that leads to the attack feasibility of the damage scenario. That's the reason why the AND and OR operators are necessary, because that goes into the mathematical formulas to calculate the propagation. Yeah, and you can do the attack feasibility in different manners. It is, of course, a qualitative estimation of attack complexity. You can do common criteria, CVSS, attack vector. You can even do likelihood if it is doable. Methodologies can be used, but there are some peculiarities depending on the modeling. Attack trees require a propagation method. As I said, that is a mathematical model. And we also have a recommendation here to do that in the system. There are many more in the market, and it depends from company to company. There are also some best practices in the standard referred to earlier, as you can see here, the ISO SAE 21434. Flexibility, second characteristic of a decent risk analysis. The living document is the subtype section. So the development of the system is typically an iterative approach, as you know. It's the V model, for instance, and you're going the left side down and the right side up through the development and the architecture and all the things up to the testing and validation and the release of the product. Changes of the system are necessary and very common, and changes in the functionality lead to changes in the risk assessment, of course. And the risk analysis needs to reflect these changes. So you need a flexible documentation, including flexible representations of the system model. So what does that mean? If you just have a textual description of your vulnerabilities, you might end up in a lot of work, a lot of effort if something in the system changes. Right? And here is an evaluation of what you can do. We are seeing a lot of Excel spreadsheet tooling for doing risk analysis. It's the common way, still the common way, even if there are some first products on the market to make the world better. It's the common way to document risk analysis. It's an easy distribution. You can easily extend it, and it gives the feeling, and the emphasis is here on feeling of clarity and completeness. The complexity overwhelms you, and the transparency of the risk model is not even existent, if you're asking me. If attack trees or similar complex structures are used, then modeling this in Excel is not possible. Because of the dimensions you have, Excel has 2 dimensions. You can model in, right? With some tweaks, you can make it a little bit more flexible, but it's not enough to represent attack trees. PDFs, so written text, there is no flexibility at all. Could also be a Word doc or something like that. There are some off-the-shelf tools that are available. That are also supporting some ISO SAE 21434 risk models. It supports users in developing standard but non-tailored risk analysis artifacts. In the meantime, there are some tailoring offers of the companies. However, they're in the ramp-up phase, and it is often not possible to fully integrate that into your company-specific extensions and interfaces. And there is the custom tool approach, which is an approach that we see way more often now than a year before, for instance. A custom tool that is completely tailored to your company based on their companies, also ITK, who might have a first seed of code so that you don't need to start on the green loan and build up a custom tool on top of it. It requires a little bit of maturity of your security engineering in your organization, so it should be clear what the model is, what the process is, and all the things. Otherwise, the cost-benefit ratio can be poor, of course. But if that is clear, you can really come up with a solution that is individually adapted for you in a fast way, and that's something that's really interesting if you're interested in that. And if that is something that you're looking for in your company, then don't hesitate to contact us. Recommendations on the flexibility. Attack trees are easily extendable all the time. When your product is released, when the first incidents are flying in, hopefully not, but if that is the case, then the attack trees are the best approach to really work with it. And even the risk model and the risk assessment is way easier if you're working with attack trees. The initial setup of the whole thing is maybe a little bit more complex than compared to setting up an Excel spreadsheet. But at the end, it saves you a lot of effort. And a clear integration of residual risks, for instance, the attack defense trees, which is another thing that you can easily integrate into your attack trees, can be something of benefit for you to do residual risk assessments after the product is fixed. Custom extensions to toolchain can be considered, as I already said, if the process is already established. Let's talk about the last thing, which is traceability. I see what you did there is the subtitle of that. So this is a launch track. I think it was in Portland where you can launch boats into the water, but you definitely don't want to launch your cars into the water. And if it goes to the water, if something goes wrong, then you actually want to know what kind of or what part of the risk analysis is reflecting this thing that happens. There is a life of the risk analysis after the risk analysis is the bottom line message here. And as I already said, the residual risks need to be integrated into the risk analysis and such. And questions need to be answered. What is the impact on the attack feasibility rating if residual risks are there, or if some countermeasures are implemented and things like that. And you might want to re-rate each attack path because of some changes in the system and such. And you want to have something that comes with traceability, which is repeatability. You want to have similar analysis if you are analyzing similar products, right? If one risk analysis looks like super red, and another product that is maybe similar to that and comparable to that is at green, and this is only because two different people did the risk analysis, then you have probably not the most reliable methodology. And every finding in the analysis need, of course, to be tracked, because at the end, in the testing stage, you want to reflect your risk analysis and saying, okay, we have tested this countermeasure that was implemented because of that risk that was the risk analysis. Traceability, our recommendations. Again, use of attack defense trees. Attack defense trees are subtrees in the attack trees to model the residual risks. So you're modeling something that lowers your overall risk, and it can be easily integrated into the existing analysis. No need to re-evaluate all the attack paths manually, and it traces, you can efficiently trace all the measures you have implemented. Derive requirements from the attack paths and its assumptions, for instance, like in ISO SAE 21434. It allows tracing of identified issues. You can derive assumptions and communicate them, and you can also derive the attack paths from the security goals, of course. A clear traceability of your system weaknesses leads to clear communication, right? And that is something we've seen many times. Yeah, there is a vulnerability in the system, but we cannot talk about that because it's not analyzed and we don't know what to do. That's not clear communication you need to have, right? If you want to tailor your development or you want to ensure that you pick and choose the right security measures, you want to have a clear communication, of course. So let me conclude what we have seen here. Risk analysis are far more than a document stating risks. It's way too expensive to just serve as paperweight. As I said, if it goes to the desk, you did something wrong. It's for security related activities, and it needs a decent methodology that needs to be tailored to your organization. It needs the process flexibility to adapt to your development processes, and it should produce traceable risks. And that's the reason. That's why these three characteristics are, from our perspective and hundreds of risk analysis in that field, are the key characteristics of a decent risk analysis to reach the full potential. With that, I hope that we got a lot of questions already. I don't know. If you have questions afterwards, not asking via the Slido, something like that, here's my email address. You can also drop me a message after today's event, of course.
Perfect. Thank you very much, Sebastian. It was a great talk and fantastic slides. I loved them. So one could see your experience in the online format and in presenting things. So very good. I loved it. So we have a lot of questions. We even have more than 25
Great.
questions, and
Wow.
I will start as always. I will start with one question, which is not from our list. So you presented us risk analysis methods, and the question one could have is how do you ensure that you took into account all aspects of the system in your risk analysis?
Mm-hmm. Actually, that's the first issue you are facing if you're running into a risk analysis project. And the way we are doing it is a workshop-based approach. So we have pre-configured workshops we do with our customers, and we have pre-meetings of that where we divide the stakeholders into groups that we think are fitting together for that discussion. So we have the communication guys in one workshop. We have the ECU guys in another workshop. We have system engineers in another workshop, and we have pre-configured questions that should ensure to guide us through the system until we know every nitty-gritty detail of the system, which is absolutely necessary. That's the most time-consuming part of it, but it really leads to a great understanding of the cybersecurity engineers. And it also leads to these discussions, as I said in the beginning, that are non-security architectural discussions that you also want to have as a value add of a cybersecurity analysis. Yeah.
Very good, very good. Maybe you directly related to your answer. So which role does communication play in a risk analysis, but also in security overall, maybe also in your role as a CISO of a company? Is communication important? Can there be enough communication? What tools are there to have efficient communication about security?
No, you can all do via PowerPoint reporting. Communication is not necessary.
Okay, good. That's what I thought.
Of course, communication is the key element, right? And I'm doing a students talk every year at the KIT, and what I'm drawing there is a picture where the CISO is in the middle of this organizational structure and needs to communicate up to the management, down to the IT administrators, back and forth with the developers, with parts of the company like quality management, quality assurance, things like that, to the IT department, of course, the CIO, the head of IT, whatever his role is or her role is. Whoever operates the IT, all these stakeholders are super important for the communication. And I think the communication circus is something that is super important. And if you want to be in this role or also the product security role, communication is a key asset you need to have. I don't know whether I make it perfect all the time, probably not. As you can see, I'm someone who is really into that cybersecurity topic and has a lot of emotions with that and a lot of passion, and yeah, that leads to cool discussions and constructive discussions that lead to cool, novel things that we're going for.
Very good, very good. So then I would hand over to Alex for the first questions from the audience.
Okay,
I'm
thank
looking
you.
forward.
Thank you, Marc-Oliver. Thank you, Sebastian, for this presentation. So there will be a lot of questions, and I will try to regroup them in specific topics, I will say.
Mm-hmm.
So the first one will be more general. So what is more risky today, hardware or software? And is it more difficult to model cyberware today than a decade ago?
I didn't get the second part of the question. There was an interrupter, but let me take the first part of it. Hardware or software? What is more vulnerable? So actually, hardware is in many cases vulnerable, right? If you can reach the hardware, then you can do a lot of things with it. You can do timing analysis. You can do whatever you want, and often the security breaks with that. However, the question is that our main problem? I would say the hardware should come up with essential things like hardware security modules that are necessary to really implement secure features or security features on your machine, right? If you don't have an environment where you can securely execute an algorithm, then you have no chance, right? Then you can do in software whatever you want, it's breakable, yeah, or it's vulnerable. But besides that, the software is of course on high risk because it's not only the security measure that can go wrong. There can be a vulnerability in the implementation of the security mechanism, but there could also be something like possible buffer overflows or something like that that is located in some other parts of the software. So the software can be vulnerable in any part of it. And that makes it really hard to analyze all the things. And I would say the risk is higher on the software part because the chance that you oversee something is much higher, and the chance that someone in the process after a risk analysis is doing something wrong because he or she implemented it in a wrong way, or it's vulnerable, what the outcome is. Yeah, that's something that is of great risk, of course.
Okay, nice. So the second part of the question was, is it more difficult to model the digital world today than a decade ago?
Yeah, short answer, yes, absolutely.
Okay, so there were now some questions about the known, the unknown. So how to manage incidents that were not modeled or anticipated? And there was a second question on this topic. I will have to find it. We don't know what we don't know. The risk analysis will be as good as a risk expert with a little help of document and standards.
Yeah. So as I said, I've sketched some or highlighted some methodologies that you can use. I make a simple example that would not lead to a full-fledged risk analysis, but you can use, for instance, the STRIDE method to go through your system. STRIDE tackles some types of vulnerabilities like spoofing, tampering, and so forth, right? And this helps you to gain completeness. But 100% completeness is not possible, of course. And of course, you will you might face the situation that there is an incident in the future that you haven't reflected in your first risk analysis. Pretty often, that's the thing. But if you have a risk analysis that can easily be adapted by another vulnerability that you haven't considered before, leads to a very fast response incident, because you can build it into your attack tree and you immediately see what happens with the risk values, right? That's the reason why it's a living document.
Okay, so you have answered other questions by answering these ones. Questions were about, can we have a 100% security of a system? And how are we assuring that the certification process is foolproof, or the completeness of the rules of cybersecurity? So I guess that the dynamicity of tools can help us.
Right. So 100% security is not possible at all. That's for sure. And if you have a very secure stage of your system, that does not mean that it is secure tomorrow, because maybe the algorithm that is secure today might be broken tomorrow, and your system is then from then on vulnerable. So that's definitely a problem. So how to tackle that? Yeah, actually, it's an expert-driven thing, as you already said, right? It depends on the experts who are doing the risk analysis. We're doing a lot of guided approaches, so where a customer is doing the risk analysis, and an expert who has done risk analysis for 10 years or something like that is accompanying this customer to do the risk analysis and to point him to certain details. But the quality is the range of quality is really large in the yeah.
Okay.
Maybe let me kick in
Yeah.
there. So, which role do insurance companies play in this risk analysis game, and which role does and it's related obviously to liability. So,
Yeah.
is this also a factor that is playing in? And so, when I think, for instance, now to be more concrete about a car manufacturer, and then you have he left.
Yeah.
Now so he'll rejoin. So yeah, you're back, perfect. So the question is, when you have a car, for instance, and then you have 98% security, and the rest you don't want to cover yourself, are there insurances for that? Are they a factor for your risk analysis? So I think you get the question a little bit.
So you were breaking up. Sorry, I need you to repeat the question.
So the question is still the one from the beginning. So what role do insurance companies play in a risk analysis?
Yeah.
Are they
Okay.
a factor that you take into account for the liabilities, or is it something that is totally out and only comes in later?
No, it's definitely not out, and it is coming up way more than 2 or 3 years ago in that field. And of course, if you have identified a risk, there are different opportunities to tackle with that risk, right? You can reduce the risk by implementing a measure, but it is also fine to accept the risk. Maybe it's acceptable. You can transfer the risk to an insurance company. That's something that is absolutely doable. And to complete that 4 things you can do, you can avoid the risk, so you redesign your system so that the risk is no more existent, right? Yeah, but insurance companies play more and more a role. I've just signed a paper where an insurance company asked about 250 questions on cybersecurity stuff to make a proposal on a fee and such for a customer of us. Yeah.
Okay, I see. And related to this, what is the result of a security analysis? Do I get a red light, green light, yellow light, or do I get a report? And related to that, who is reading it and who is understanding it, and is it well enough understandable?
Yeah. So for me, the perfect risk analysis report has different stages or different areas. So it needs to have an executive summary with an overview. We always have an overview over the most critical risks, for instance. And we give an overview on what kind of risks were found, which is definitely not more than a one-pager. then for me, a very important a part of the risk analysis report is the description of the methodology, because we have seen there are so many degrees of freedom to do that. So you need to have a clear understanding of what kind of methodology was used. And the third thing is, yeah, you need to have an overview over the details, how you come to the risks. So I call it the reasoning section, and maybe this is also only the section that is read by the experts. That could be the case. Yeah.
Okay, cool. Thanks. Then back to Alex.
Okay, back to other questions. So there were two questions about the machine learning field. So are all, I will say, risk analysis made by human experts, or machine learning is helping? And the same question about the attack trees and simulation process to test hypotheses on risk assessment.
I like the question. That's nice. When you first said machine learning and artificial intelligence and such, I was thinking a question comes up that goes in the direction of cybersecurity for machine learning algorithms, because that is a research field, and a professor of Brunswick is very famous on that. But this question went in a total different direction. Actually, since the methodologies are so diverse at the moment and are yeah, getting consolidated now more and more based on the standard that was recently released, I can imagine that more automation goes into that. Yeah. For instance, we have built up a tool to do risk analysis for one of our customers, and in this tool, you definitely already have some automation. I would not speak of machine learning algorithms yet. I would definitely not talk about AI things yet, but there is at least a certain amount of automation that saves time. Yeah.
Okay, thank you. Yeah.
And maybe let me kick in. So
Sure.
if you consider that the AI could take some of the tasks, and then my direct follow-up question would be, what about the human in the loop? So would you give it one hour? It's a super personal, and in the same time,
Yeah.
I mean, it's just your personal judgment for the moment. So the answer will be different in 1 year, for instance. But it's still interesting for me. So this human in the loop, would you say it will be possible to have an AI that is reliable enough to do the full risk analysis, for instance, to really make a bold claim?
Yeah, tricky question. So actually, I'm the guy, when I did my PhD in security and privacy at the KIT, at Professor Hartenstein's research team, he once asked me, and that is more than 10 years ago, do you believe we have autonomous cars in 10 years? And surprisingly for everyone in the room, I was saying, I don't believe in that. And the only one of that room who was right was me, right? Now 10 years later, we don't have autonomous cars on we do have some autonomous cars and some autonomy, but we don't have full-fledged autonomous cars driving down the road, right? So same here. I don't believe that. I can believe that a lot of automation goes into the risk analysis. I can also believe that some might optimize towards the regulations, which might lead to effortless risk analyses. I don't want to judge that, but it's a risk, maybe. Yeah. And maybe it also goes to engineers from best cost countries, which might lead to decent risk analyses because the knowledge in those countries are raising up. It's astonishing and amazing how this develops, but at the moment there is still a gap, and that could also influence the thing. But I don't believe in AI in the next years for risk analysis.
And maybe for the audience, as a little bit background for why we think AI could be good, is that AI allows you to do fuzzy analysis. So that means if we put something in and then we have a concrete system, the AI could allow that the algorithm adapt to the system and give some result.
Sure. So I'm not saying that IA does not play a role at all for the risk analysis, but I don't
Sure.
believe in AI is the thing that is doing the whole risk analysis.
Yeah, and I would also agree with you. So that it's and this is also why I asked for the human in the loop, because it's
Yep.
Even though the AI is or the machine learning is deterministic in its parts, it still needs a little bit more than mechanics. So it's not really
Absolutely.
only following the cookbook, but at the same time, of course, it's also a little bit following the recipe in the sense that it's a standard, and it's good that it says that the methods are standardized, because like that you have somehow comparable results. And
Yeah.
yeah.
But
Okay.
there's one interesting fact on that AI thing. If we are able to let AI algorithms do the risk analysis, maybe AI algorithms are also capable to help the attackers in the same manner, right?
And they are just, I don't know if you're aware of that. So I was just sending in an EU proposal to the last week, and in that they proposed also to look at how AI can change the attacker landscape. And this would also have been a related question by me. So is AI already playing a major role in the risk analysis? Do you assume that you have AI-based attackers? Is that considered already? Or is it already covered by the methods because they are generic enough and therefore it doesn't matter?
I hope that this gets approved, what you have handed in, because I really appreciate that someone is going forward on that, because I believe that's something that will be taking place earlier than we put full-fledged AI risk analysis in place.
That's good. And but you would say it's considered. So if you have AI-based attacks, the risk analysis methods are enough considering it already. Okay, very
Absolutely.
good. So back to Alex.
Yeah, nice. So there were some questions about the risk analysis as a tool. So where in the life cycle of a product does it make sense to make a risk analysis? Does the result change over time? And how much does cost a risk analysis? And there were a third question. I will try to find it. Yeah, I will ask it after that because it's a more tricky one.
Yeah. Okay. So in the best case, a risk analysis should be kicked off when the first architectural pictures of the system are in place. But often that is not the case. We need to face the reality, right? Cybersecurity kicks in later in the process in many projects, and that's all fine, right? The thing is, especially in it's sometimes hard to really follow up with the risk analysis, because that is something that needs to follow the architectural changes all the time, and that can lead to cost explosions afterwards. I don't say that agile is not a good approach. The complete opposite. All our development projects are running in an agile manner, and I think that's the only way modern development works, right? But yeah, for the risk analysis, this is really an issue that need to be solved. Talking about the cost, I don't want to drop numbers, but I've seen risk analysis in the $4-digit dollar area up to the 8-digit area.
Okay.
And maybe related to that, what is the ratio between the costs and the savings? Because this is always a trade-off. Because in the end, the key problem of security is like, do I invest in security? And if you never have a security incident, I would say, as a risk analyst, I would say, no, don't invest. But if you have the first incident and it's like way high, then of course it's worth investing.
I mean, we're seeing projects that are tiny little products that need a risk analysis, then we're in a lower area. And if I talk about the few ones that are in the millions, then we're talking about large systems with a lot of ECUs, hundreds of ECUs in some cases, talking to each other and talking to the outside world, right? And if you're thinking of an IoT device that is a tiny device that costs $100 or something like that, then you don't want to have a risk analysis that costs you $1 million, right? Then you're out of the game. The return on security invest, there's a lot of research on the ROSI, the return on security invest, in the beginning of the 2000s, right? And they all come to the conclusion the ROSI is what you do not have to spend due to attacks in the future, right? And that's the question. It depends on how hard an attack would be for your company. For some companies, they say if we get an attack based on that, we are done on the market. So it's betting the farm. Yeah. And if you then invest $1 million for risk analysis or even more, then it might be worth to do it. But you will never know whether it was worth or not, right? On the other hand, if there is no risk because you have a tiny little device that sits in a super facility with all the things around that, physical security around that, then you might not want to have a risk analysis in that effort area.
And how is the interoperability of risk analysis reports? So I'm thinking now about a car, for instance. You have different providers of ECUs, and they are all doing risk analysis. And you are the car manufacturer in the end that also has to do risk analysis. Is that standardized? Are they all using the same methods? Is the manufacturer implying to their suppliers, you have to do this process because otherwise you're not compatible with me? Or what is the current status there?
That's the reason why the attack tree approach is for many OEM companies, manufacturers, the way to go. Not for all, definitely not for all. There are also the OEMs going for Excel spreadsheets, listings, and such. It leads to hundreds and thousands of lines of Excel. Maybe that is no more usable. I don't know. Attack trees are a little bit easier to integrate if they are done with the same methodology. The easy answer to that, it's getting better. But at the moment, we don't see homologous methodologies.
Okay, cool. Back to Alex.
Okay, so now about risk analysis, a tricky question, I will say, or two questions. So the first one is, are there methods to integrate ethical consideration on risk analysis as opposed to more legacy metrics, e.g. related to economical impact? And the second question related to the first one is, any comments on the Volkswagen's pollution emission test scandal? Do you think they analyze the risk of being discovered and the impact of it?
So I cannot answer a question like the second. Sorry, but I like the first one. So what are the ethical aspects around such a thing? I mean, there are many fields where you can look at the ethical aspects. For instance, you need to really dig deep into the architectural things, and sometimes we open up a box in the discussion that people try to keep close, even in the companies, right? And sometimes we're standing there, didn't see that coming before, and then somebody needs to defend himself or herself because something was covered, right? And then you instantly are in a personal ethical discussion with yourself. Is the thing that you're doing good for the end customer by at the same time damaging a career or something like that? It does not happen very often, but I've seen it 2 times at least. And that was a point where I was in a personal ethical conflict, I would say.
Okay. So yeah, so now more light questions, but quite kind of related, I think, of your dilemmas you maybe have faced. What was the weirdest security-related thing in your life that you can talk about? And another question, which is a bit linked, in my opinion, who is the most important person concerning concerning company cybersecurity?
Okay, tough questions. What is the weirdest thing? Oh, I've seen so many weird things on security. So maybe I'm referring to the airbag hack I was showing in the sample attack tree. That was done by a student, and he showed that in the standard of how to deploy an airbag at end of life was a mistake. So you can imagine how how broad this attack was deployable. And that was something where I was saying, whoa, now we have to talk to companies, or you, the student, have to talk to the companies because they need to do something, right? And he did it, and it was a cool discussion. He said, in the meantime, he's one of our cybersecurity engineers. He's in a pen testing team, and is doing a great job on finding things. So if you think your system has no vulnerabilities, I'm sure he can find it. So that's maybe the weirdest thing I've seen, because I've really seen it working. So we had a task car in one of our great halls of testing, and actually let the airbag thing work, right? And that was scary. Yeah,
Okay.
absolutely. But weird are all the security circus things. Do you know what security circus refers to? That is, you have a lot of, in German we say pappmaché, a lot of facades up front, and back then you're not doing anything. So mechanisms that are implemented on many ECUs, but activated, things like that. Also some things to
Thank you.
that. Yeah.
Thank you for this answer. So now there were two questions that are not related but asked by the same person. The first one was about the ISO norms, I think. So the question is, I see that there is a 2021 version of the 21434 norm, I think.
Yep.
Regarding cybersecurity aspects, do you think there are some new aspects or approach that the 27005 could benefit?
Uh, Actually, these are two different fields, right? So the 2701 is the information security management system. Yeah, the CISO is the one who is driving that, and there is certification opportunities, and it simply says, probably the ISO guys wouldn't like me if I say that, but maybe they forgive me. It's the 2701 says, have your risk analyzed and decide what to do with the risk. And that across your company, physical security, IT security, whatnot, right? And the 21434 refers to a cybersecurity management system. So for vehicles in that case, or for machines, whatever, right? And here you have two dimensions that are not represented in the ISMS, which is you have a company level that is maybe a little bit comparable with the ISMS, and then you have the actual instance of the product. And that makes the two things completely different. The ISMS is for the one company or the one part of the company, and it has one instance. Yeah, it is one. The number of real world instances is one for the ISMS. In the product world, you have one policy over or umbrella over it, and then you have millions of instances, which makes it completely different. So it's not really comparable. Yeah.
Okay.
And the requirements are going much deeper than in the ISO 2701, but it does not have any how to say any the one is derived from the other or something like that. That's not the case. There are definitely similarities, and you can find some things in both standards, but two different things.
Okay, nice. And one other technical question. With the cloud approach, we are putting our assets in the same tank as the sharks. Is this something that automotive industry is facing?
Sure. I mean, a lot of automotive companies are have implemented their own cloud solutions. Some of them are hosted on-premise at the OEM, so that they have full control over the data that flies from the cars to the cloud solution. But some of them are migrating some services into the cloud services like Azure or AWS and things like that. But they are kind of stepping one foot after the other in that direction because of the privacy issues you have, because of you need to have an exit strategy. What if Microsoft goes in the hands of someone you don't trust in the future or something like that? So you need to have exit strategies and things like that. So it's kind of tricky. We see that trend, but it's slowly going forward.
Okay.
By the way, compared to all IT services in the world, I've just learned from Amazon that only 5% of the IT services are in the cloud business. And if you're going to the automotive industry, it's a tiny, tiny bit of that 5%.
Okay. That's
Which does not mean that they have cloud-like solutions. Yeah, they all offer, but it is often hosted on-premise in their own computing centers.
Okay, yeah, very interesting fact that can be studied by some person. So there were lots of questions now, but very precise. So I don't know if we have the time for them. About, for instance, attack trees. So what were the color in your attack trees, and how do you create such trees? And do you always use them or not? So if you feel free to answer quite quickly, I think, to this kind of questions.
Yeah, so the color scheme is not the best color scheme because it has green and red in it, and some people cannot see that. But it reflects the mathematical end tuple behind the evaluation of the attack feasibility. So if it's a very critical item, then it's more red. If it's a less critical item, it's more green and yellowish in between, right? What was the second part? Sorry.
How do you create such attack trees, and do you always use them?
Yeah, in most cases, we do use attack trees if it's possible. If we are in a very abstract environment, we try to not model the 37th hierarchy of the attack tree because that's going into too much effort for the gain I have. Yeah.
Okay. And do you have specific tools designed by yourself, or are you using some on-the-shelf tool?
We're not using an off-the-shelf tool. We're using our own tool. As I said, we have we call it a nucleus or a core of that tool on top of which we can build up individual tools for our customers. As I said, we did that a couple of times before in providing that service, but it's highly individually designed for the target company, and we're using that internally as well. But we are also working in our customers' tools. So sometimes they bought off-the-shelf tools and we're using it. Yeah.
Okay, thank you.
Depends on the project.
Yeah, of course. And there were another two questions very precise about the V model. So how does the V model help for cybersecurity? And could the V model help securing other domains?
I would say it helps. As I said, I'm an agile, passionate guy. Yeah? But on the other hand, the V model really helps to do one step after the other, and it is less likely to step back to an architectural change that influences the cybersecurity assessments too much, right? And that definitely helps.
Okay, nice. And so just to finish, so there were a remark, I haven't seen it, sorry, about machine learning and how it could be used to automate some analysis. Someone said that good experts can teach the machines well.
Sure. Yeah, I would agree. Yeah.
Yeah, but the machines, when you have an online learning, etc., they will also continue learning. And plus, the thing that you never know is the concrete system you put the machine learning algorithm to. And that means even if you taught it well, if you have a system that is totally different from what you taught before, you don't know what it will do. So a good comment. I also agree, but it does unluckily not solve the problem.
That's, by the way, the reasoning why I said that machine learning and I don't see it in a full-fledged manner for the risk analysis because the heterogeneity of the systems. We are not talking about IT servers where Windows server or a Linux server sits on, and it's always kind of the same. Depart some configuration items and something like that. We're really talking about individual systems. They even design the hardware individually for the product, and then the security situation is something completely different than compared to another product, right?
And to conclude the audience questions, which car manufacturer has the lower risk, and do you feel safe in today's cars?
So I'm driving a connected and highly equipped car because I'm also a tech freak and a car freak, as you have seen in the car I've shown has not so many technique. It has an engine and 3 pedals and nothing more, right? 4 wheels and a monocoque. But I do drive a connected car, and I do feel safe in that car. However, if we're not speeding up the budget or raising the budgets and speeding up the process on cybersecurity, which is now initiated by the UNECE, and I really appreciate that. If companies are not following up, they will not get type approvals in the future, and that will lead to less companies on the market. But those will stay who at least did a decent cybersecurity process.
Okay, so thank you for your answers, and back to you, Mark Oliver.
Thank you.
Great. That was fantastic. So I enjoyed the discussion at least as much as I enjoyed the talk, and the talk was already great. So I think I didn't promise you too much, Sebastian, but we always have great questions from the audience.
Absolutely.
So first of all, big thank you, Alex, because the last 2 runs were without you, and it's releasing me a lot when you're moderating the questions. So you did a great job. Thank you very much for that. And thank you very much, Sebastian. It was a great talk, a great presentation, and it was really perfect for the audience because you really managed for this difficult topic to get in between the details and also the general information, and also with your answers to the questions. So it was definitely a highlight of the series. And yeah, thank you very much.
Thank you for inviting me. It was a real pleasure and a real honor to be on the list of your speakers, because the list is a great thing already, and being part of it makes me proud. It was a lot of fun. You're welcome, and thank you as well.
Great. And if you want to contact Sebastian, his address is still visible there. So yeah, that brings us to the end of today's series. I use the opportunity to inform you once again about our PhD school that you find here in the banner. Have a look at the website, at the program. You can all follow online, and those of you who want to participate on site, you have lots of benefits like getting to know people, doing the challenges on site, etc. So it's definitely worth. Share the link also with your friends and the info, so that we get a full auditorium. So we still have some seats left, and it's not so much time that is left, and RAN is definitely worth a visit. All right, so that said, the next edition will be on the 24th of November, and on the 24th of November we'll have Mohamed Hamad from TU Munich, and he will talk about multi-layer cybersecurity framework for the Internet of Vehicles, needs, requirements, and solutions. And in that session, you can directly look at if he took into account the cybersecurity risk analysis details that Sebastian was talking about, or if he's telling us something totally different. So stay tuned for that. See you in 1 month. And yeah, it was a pleasure. I will show you in the outro a picture of Mohamed, and yeah, see you in 1 month. Goodbye.
Cher Cybersecurity Pôle d'excellence Région Bretagne. Au revoir et à la prochaine.